OCaml, originally known as Objective-CAML, is the main implementation of the CAML programming language, created by Xavier Leroy, JAR copyright Rami Vowilen, Damien Deliges, Didier Ra copyright Mai, Askander Suarez and others in 1996. OCaml extends the core CAML language with object-oriented constructs. OCaml's toolset includes an interactive top-level interpreter, a bytecode compiler, a reversible debugger, a package manager, and an optimizing native code compiler. It has a large standard library that makes it useful for many of the same applications as Python or Perl, as well as robust modular and object-oriented programming constructs that make it applicable for large-scale software engineering. OCaml is the successor to CAMLite. The acronym CAML originally stood for Categorical Abstract Machine Language, although OCaml abandons this abstract machine. OCaml is a free open-source project managed and principally maintained by INRIA. In recent years, many new languages have drawn elements from OCaml, most notably F and Scala. Philosophy: ML-derived languages are best known for their static type systems and type-inferring compilers. OCaml unifies functional, imperative, and object-oriented programming under a milliliter-like type system. This means the program author is not required to be overly familiar with a pure functional language paradigm in order to use OCaml. OCaml's static type system can help eliminate problems at runtime. However, it also forces the programmer to conform to the constraints of the type system, which can require careful thought and close attention. A type-inferring compiler greatly reduces the need for manual type annotations. Nonetheless, effective use of OCaml's type system can require some sophistication on the part of the programmer. OCaml is perhaps most distinguished from other languages with origins in academia by its emphasis on performance. Firstly, its static type system renders runtime type mismatches impossible, and thus obviates runtime type and safety checks that burden the performance of dynamically typed languages, while still guaranteeing runtime safety. Aside from type-checking overhead, functional programming languages are, in general, challenging to compile to efficient machine language code, due to issues such as the FUNAG problem. In addition to standard loop, register, and instruction optimizations, OCaml's optimizing compiler employs static program analysis techniques to optimize value boxing and closure allocation, helping to maximize the performance of the resulting code even if it makes extensive use of functional programming constructs. Xavier Leroy has stated that OCaml delivers at least 50% of the performance of a decent C compiler, but a direct comparison is impossible. Some functions in the OCaml standard library are implemented with faster algorithms than equivalent functions in the standard libraries of other languages. For example, the implementation of set union in the OCaml standard library in theory is asymptotically faster than the equivalent function in the standard libraries of imperative languages because the OCaml implementation exploits the immutability of sets in order to reuse parts of input sets in the output. Features: OCaml features a static type system, type inference, parametric polymorphism, tail recursion, pattern matching, first-class lexical closures, functors, exception handling, and incremental generational automatic garbage collection. OCaml is particularly notable for extending ML-style type inference to an object system in a general-purpose language. This permits structural subtyping, where object types are compatible if their method signatures are compatible, regardless of their declared inheritance. An unusual feature in statically typed languages. A foreign function interface for linking to C primitives is provided, including language support for efficient numerical arrays and formats compatible with both C and Fortran. OCaml also supports the creation of libraries of OCaml functions that can be linked to a main program in C, so that one could distribute an OCaml library to C programmers who have no knowledge nor installation of OCaml. The OCaml distribution contains an extensible parser and macro language named CAMLP4, which permits the syntax of OCaml to be extended or even replaced, lexer and parser tools called OCamlex and OCamliac, debugger that supports stepping backwards to investigate errors, documentation generator, profiler for measuring performance, numerous general-purpose libraries, The native code compiler is available for many platforms, including Unix, Microsoft Windows, and Apple Mac OS X. Portability is achieved through native code generation support for major architectures, IA32, 64 Armenian DRAMs, Power, SPARC, ARM, and ARM64. OCaml bytecode and native code programs can be written in a multi-threaded style, with preemptive context switching. However, because the garbage collector of the INRIA OCaml system is not designed for concurrency, symmetric multiprocessing is not supported. OCaml threads in the same process execute by time sharing only. There are however several libraries for distributed computing such as Functory and OCaml Plasma. Efforts are being made to extend the OCaml garbage collector to support concurrency, and true support for concurrency is expected to be built into the language by version 4.03 in fall 2015. Development environment. Since 2011, a lot of new tools and libraries have been contributed to the OCaml development environment, OPAM. The OCaml Package Manager, developed by OCaml Pro, is now an easy way to install OCaml and many of its tools and libraries. Optimizing compilers for OCaml. JS of OCaml, developed by the Oxygen team, is an optimizing compiler from OCaml to JavaScript, to creative apps in OCaml. OCaml is a compiler from OCaml to C, to complement the native code compiler for unsupported platforms. OCaml Java, developed by INRIA, is a compiler from OCaml to the JVM. OCaPIC, developed by Lib6, is a compiler from OCaml to PIC microcontroller. Websites. OCaml.org is a website managed by the OCaml community. Try OCaml, developed by OCaml Pro, is a website containing a complete OCaml REPL in a web page. Development tools. TypeRex is a set of open-source tools and libraries for OCaml, developed and maintained by OCaml Pro. Merlin is an auto-completion tool for editing OCaml code in Emacs and Vim. Code examples. Snippets of OCaml code are most easily studied by entering them into the top level. This is an interactive OCaml session that prints the inferred types of resulting or defined expressions. The OCaml top level is started by simply executing the OCaml program. $OCaml, Objective-CAML version 3.09.0. Code can then be entered at the pound prompt. For example, to calculate 1 plus 2 times 3. Number 1 plus 2 times 3. Int equals 7. OCaml infers the type of the expression to be int, and gives the result 7. Equals hello world equals, the following program ALll. Can be compiled into a bytecode executable. $OCaml hello MLO hello. Or compiled into an optimized native code executable. $OCaml opt hello MLO hello. And executed. $hello, hello world. Equals summing a list of integers equals, lists are one of the fundamental data types in OCaml. The following code example defines a recursive function sum that accepts one argument xs. The function recursively iterates over a given list and provides a sum of integer elements. The match statement has similarities to C's switch element, though it is much more general. Sum 1, 2, 3, 4, 5. Int equals 15. Another way is to use standard fold function that works with lists. Sum 1, 2, 3, 4, 5. Int equals 15. Equals quicksort equals, OCaml lends itself to the concise expression of recursive algorithms. The following code example implements an algorithm similar to quicksort that sorts a list in increasing order. Equals birthday paradox equals, the following program calculates the smallest number of people in a room for whom the probability of completely unique birthdays is less than 50%, for 2 it is 364/365, for 3 it is 364/365, 363/365, etc. Equals church numerals equals, the following code defines a church encoding of natural numbers, with successor and addition. A Church numeral n is a higher-order function that accepts a function f and a value x and applies f to x exactly n times. To convert a Church numeral from a functional value to a string, we pass it a function that prepends the string s to its input and the constant string 0. Equals arbitrary precision factorial function equals. A variety of libraries are directly accessible from OCaml. For example, OCaml has a built-in library for arbitrary precision arithmetic. As the factorial function grows very rapidly, it quickly overflows machine precision numbers. Thus, factorial is a suitable candidate for arbitrary precision arithmetic. In OCaml, the num module provides arbitrary precision arithmetic and can be loaded into a running top-level using. The factorial function may then be written using the arbitrary precision numeric operators equals slash, slash and slash. This function can compute much larger factorials, such as 120. The cumbersome syntax for num operations can be alleviated thanks to the OCaml syntax extension called delimited overloading. Equals triangle equals. The following program OCaml renders a rotating triangle in 2D using OpenGL. The ALL bindings to OpenGL are required. The program may then be compiled to bytecode with $OCaml plus LABLGL labglud kmar LABLGL kmar simpleml simple. Or to native encode with $OCaml plus LABLGL labglud CMXA LABLGL CMXA simpleml simple. And run. $/simple. Far more sophisticated, high-performance 2D and 3D graphical programs can be developed in OCaml. Thanks to the use of OpenGL and OCaml, the resulting programs can be cross-platform, compiling without any changes on many major platforms. Fibonacci sequence equals, the following code calculates the Fibonacci sequence of a number n inputted. It uses tail recursion and pattern matching. Higher order functions equals, functions may take functions as input and return functions as result. For example, applying twice to a function f yields a function that applies f2 times to its argument. The function twice uses a type variable a to indicate that it can be applied to any function f mapping from a type a to itself, rather than only to int functions. In particular, twice can even be applied to itself. Derived languages MetaOCaml equals, MetaOCaml is a multi-stage programming extension of OCaml enabling incremental compiling of new machine code during runtime. Under certain circumstances, significant speedups are possible using multi-stage programming, because more detailed information about the data to process is available at runtime than at the regular compile time, so the incremental compiler can optimize away many cases of condition checking etc. As an example, if at compile time it is known that a certain power function xn is needed very frequently, but the value of n is known only at runtime, you can use a two-stage power function in MetaOCaml. As soon as you know n at runtime, you can create a specialized and very fast power function. The result is the new function is automatically compiled. Other derived languages OCaml provides a synchronization primitive for atomic execution of code. ALll is a subset of OCaml that uses a design rule verifier to enforce object capability, security principles. F is a Microsoft.NET language based on OCaml. Fresh OCaml facilitates the manipulation of names and binders. OCaml adds extensional polymorphism to OCaml, thus allowing overloading and type-safe marshalling. OCaml integrates constructions for developing concurrent and distributed programs. OCaml extends OCaml with features such as XML expressions and regular expression types. OCaml P3ALL is a parallel programming system based on OCaml and the P3ALL language. Software written in OCaml, Mirage OS, a unikernel programming framework written in pure OCaml, Hack, a new programming language created by Facebook, which is an extension of PHP with static typing. Hack's compiler is written in OCaml. Flow, a static analyzer for JavaScript created at Facebook that infers and verifies static types for JavaScript programs. OInstall, a multi-platform package manager, XCP, the Xen Cloud Platform, an open-source tool stack for the Xen Virtual Machine Hypervisor, FFTW, a software library for computing discrete Fourier transforms. Several C routines have been generated by an OCaml program named GENFFT. Unison, a file synchronization program to synchronize files between two directories. mDonkey, a peer-to-peer client based on the aDonkey network. GeneWeb, free open-source multi-platform genealogy software. The Hakes compiler, a free open-source compiler for the Hakes programming language. FrameC, a framework for C programs analysis. COC, a formal proof management system. Oxygen, web development framework. OPA, an open-source programming language for web development. Commercial users of OCaml. There are several dozen companies that use OCaml to some degree. Notable examples include Jane Street Capital, a proprietary trading firm, which adopted OCaml as its preferred language in its early days. Citrix Systems, which uses OCaml and Xen Server, a component of one of its products. Facebook, which developed Hack, Flow, and PFFF, RE Site Explorer, which uses OCaml for its back-end framework. See also, CAML and CAML Lite, languages from which OCaml evolved. Standard ML, another popular dialect of ML. Extensible ML, another object-oriented dialect of ML. Haskell, an object-oriented extension to the functional language Haskell. References. External links: OCaml Language Family official website.